In this example, we need to find the absolute maximum and absolute minimum values for the function f of x equal to x e to the minus x on minus 4, 6. So let me remind you this. For function f, this one is continuous. So in general, for any function f is continuous. And if they give us a closed interval, so in our case, it is closed interval. We count the two endpoints here, minus 4 and 6, on a closed interval, say AB. Then we can always find absolute max and absolute minima. So here how we do it. We first locate the critical point. Critical point. We might have more than one critical point. So critical points, let me call that C is a critical point. If either f prime at C does not exist or f prime at C equal to 0. So you locate all the critical points you have. And second, you compute the value of f at the two endpoints. You compute f of A and f of B. And then you compare f of A, f of B with f of C. Compare. And then the largest and the smallest values, the largest one between this one, and this one, f of C, compare f of A, f of B, and f of all the critical points you have, C1, C2, C3. Compare them. Maybe C1, C2, C3 here. The largest one gives us absolute maxima. So we might have, for example, this one equal to this one. So we have two maxima, for example. And the smallest give us absolute minima. So let's apply this for our case. The function f, this one is nice. It is continuous and actually it is differentiable. We can compute the derivative. F prime of x, you use a product rule. X prime equal to 1 times e minus x, x times e minus x prime. So I just draw e minus x here, plus x times minus 1 e minus x. Here I use this rule. So for example, e to the u prime times e to the u. U here you can think of that as minus x. So now I can group e to the minus x outside. E minus x inside I have 1 minus x. F prime of x always exists. This one equal to 0. If and only if 1 minus x equal to 0. If and only if x equal to 1. This is because this one is never be 0. So f prime of x equal to 0 if and only if x equal to 1. So this means we only have one critical point. And we call it C equal to 1. Now you have one critical point C. You have this endpoint minus 4 and this endpoint 6. You compare them. F of minus 4 equal to something. F of 6 of 1. Compute all of them and find the largest and smallest one. F of x equal to this. So f of minus 4 equal to minus 4e minus minus 4. Minus 4 exponential 4. 6e minus 6 and 1e minus 1. E minus 1. So now you see that the exponential function. So here we have e is 4, e minus 6, e minus 1. Compare them. You know that the first one is negative. For sure this one is the smallest one because this one is positive, this one is also positive. So this is the smallest. And therefore the absolute mean is f minus 4, which is minus 4e power 4. So at least we get one done. Absolute mean is e minus 4e power 4. Now we need to compare this one and see which one is bigger. I know that this one is much smaller than this one. The exponential function look like this. E power minus x is here, e power minus 1 is somewhere here. And to show that for you, I write e6 times e power minus 6 less than e power minus 1. I multiply both sides by exponential of 6. e6 times 6e minus 6, e6, e minus 1. This one and this one give us 1. So 6 less than e power 5, which is true. And therefore, this is true. So we have the largest one is e power minus 1, largest. And therefore, this is our absolute maximum. Absolute maximum is f upon equal to e minus 1. So that is our answers for the absolute max and absolute mean. This one and this one.